Let's try to graph this cubic here using first, second derivative test and find the inflection point and whatnot. All right, so the first step is to take the first derivative. It's just 3 minus 3x squared. We're going to set this equal to 0 to find any critical points, at least max or min potentials. So we're looking at x squared is equal to 1, which means x equals plus or minus 1. We use the first derivative test here. I'm going to use, say this number line here, I'm going to go from -1 and 1 are my two key points. I'm going to look for y prime values. Y prime values in each of these three spots. So I'm looking for a value of the first derivative at a value below -1, in between -1 and 1, and above -1. So less than -1 is -2. That'll be fine. I mean, you can put any number less than -1, but -2 shouldn't be too bad. So we're going to use y prime one, so minus 3 times -1 squared. That's we don't want -1. I want -2. Excuse me. Why is that coming out of 0? So -2 is what I had said. I did not write. Okay, so that's 3 minus 12, which is -9. That's less than 0. So I'm going to draw a minus sign here, indicating that the slope is coming down from -infinity to -1. All right, so a number between -1 and 1, 0 is a good one. Everything just goes away. There's just 3. The -3x squared goes away. It's greater than 0. So this is positive between these two. And we'll just do 2. That's a number above 1. This is also -9. So negative. So what we have here is our derivative is negative at values below -1, and then positive after that. That means the slope is coming down up until we get to -1. Positive after that. That means this is a min. And vice versa, going up and then down is a max. Now, I can wait, but I might as well just find out what those actual points are. So I'm going to evaluate f at -1 to find out what the min actually is, the whole thing. So I'm going to use this guy here instead. 4 plus 1 minus 1 cubed. 7 minus 1 is 6. So we have a minimum that's -1 and 6. And then the other one, and that's just wrong. Hold on a second. That's not a 1, that's a -1, and that's a -1. So let's try that again. So that's 4 minus 3, and a minus 1 is +1. So that equals 2. So there's a minimum at -1 and 2. All right, let's see if I can do this one right. This is what's going to be 6. Yeah, this is going to be 6, so we have a max at 1 and 6. All right, so those are two key points. Now, Clearly, we've got a max and min. There should be a point of inflection between them. And I can certainly take a second derivative. So let's do that over here. What's my second derivative? So that's derivative of 3 is 0. Derivative of negative 3x squared is negative 6x. I can set that equal to 0. Find a point of inflection. And that means x will have to equal 0. So that point of inflection, we're going to evaluate the function at 0. So f at 0 is going to be 4. So the point of inflection will be equal to 0, 4, which will also happen to be our y-intercept, so we don't have to go looking for that. Let's see. Let's see if we can graph this out. Or you know what? I'm gonna perform the second derivative test anyway, just to show you the values there. We don't have to do this because we found the values with the first derivative test, but let's just do it. All right, so we've got our second derivative there. So let's evaluate those at negative 1 and 1. So f double prime of negative 1 is negative 6 times negative 1, which is 6, which is greater than 0. And greater than 0 indicates we have a min, which is what we found. And f double prime of 1 is negative 6 times 1, which is negative 6. That's less than 0. So there we have a max. So again, we found the same thing that we did in our original ones. So let's try to graph this sucker. We've got enough information to graph it now. Let's see. Going up 6. Make those 1 and negative 1, whatever. So our point of inflection was at 0, 4. Let's graph this. So we have a point of inflection here at 0, 4. We had a minimum at negative 1 and 2. We had a maximum at, 6 and 1, was it? 1, 6, excuse me. And it's a cubic, so it's going to be doing something along these lines, coming down from there. And then at some point, it's going to cross the x-axis. And let's look back at our equation. So 4 plus 3x minus x cubed. That's not anything we're going to be able to factor. That's not anything we're going to be able to find that value without use of a calculator at this point. So I'm not going to worry about it. If it's something that we could use a quadratic on without an issue, that would be fine. It is not. So this is going to be our graph. And all of that other information is what led us to this graph. And that is how you use calculus to do a cubic.